November 1944. A Wehrmacht soldier lies dead in the snow outside Bastogne. American medics move past him without stopping. But German intelligence officers circled back after dark. They are not looking for documents or maps. They are looking for the rear sight assembly on his rifle. By January 1945, German ordnance depots had accumulated dozens of M1 Garand rear sights stripped from battlefields across France and Belgium. Technical analysis reports were being filed weekly. The conclusion was always the same. The Americans had achieved something that should not have been possible with iron sights. They had created a targeting system so effective that trained riflemen were consistently hitting man-sized targets at ranges where German infantry were still firing for suppressive effect. The aperture sight on the M1 Garand represented a fundamental reimagining of how a soldier acquires a target. It was not invented for the Garand. Aperture sights had existed in target shooting for decades, but the Garand made it standard issue for frontline infantry, and in doing so, altered the engagement mathematics of rifle combat across two theaters of war. The problem facing military rifle designers in the 1930s was optical, not mechanical. The human eye struggles to focus on three objects simultaneously. A traditional open rear sight requires the shooter to align three focal planes: the rear notch, the front post, the target. Only one can be in sharp focus at any given moment. Shooters are trained to focus on the front sight and let the rear blur slightly, but this introduces error. The eye must constantly shift focus. Alignment becomes approximate rather than precise. At 300 meters, a minor error in sight picture translates to a miss by several feet. The aperture sight eliminated one entire focal plane. Instead of a notch, the rear sight consisted of a small circular opening, typically 0.070 inches in diameter on the M1 Garand. The shooter looked through this hole, which the eye does not attempt to focus on. The human visual system naturally centers objects viewed through small apertures without conscious effort. This is a function of the eye's depth of field response. When light enters through a small opening, the eye perceives everything beyond that opening with extended clarity. The result is that the shooter focuses only on the front sight post and the target, with both appearing simultaneously sharp. Alignment happens automatically. The M1 Garand's aperture sight sat on a base that could be adjusted for windage and elevation via precision-threaded knobs. Each click of the windage knob moved the point of impact 1 minute of angle. At 100 yards, 1 minute of angle equals approximately 1 inch. This gave riflemen the ability to zero their weapons with unusual precision. The aperture itself was mounted on a rotating disc. One side held a smaller aperture for long-range precise fire. The other held a larger ghost ring aperture for close-quarters combat, where speed mattered more than precision. The shooter could flip between them without tools. Testing conducted at Aberdeen Proving Ground in 1940 demonstrated the practical advantage. Riflemen using M1 Garands with aperture sights achieved first-round hit rates of 68% against man-sized targets at 300 yards under field conditions. Riflemen using Springfield 1903 rifles with traditional open-notch sights achieved 41% under identical conditions. The margin widened at 400 yards, where Garand shooters maintained 52% accuracy, while Springfield shooters dropped to 28%. These were not elite marksmen. These were standard infantry with average vision and average training. The first significant combat data emerged from Guadalcanal in late 1942. Marine Corps after-action reports noted that Japanese infantry armed with Arisaka rifles equipped with traditional open sights were being engaged and suppressed at distances where they could not effectively return fire. The Japanese had excellent rifles. The Type 38 and Type 99 were robust, accurate weapons, but their open rear sights required the same three-point focus alignment that slowed target acquisition and reduced hit probability. Marines reported being able to engage targets at 400 to 500 yards with confidence. Japanese return fire at those distances was largely ineffective, not because their rifles lacked range, but because their soldiers could not achieve sight pictures quickly or accurately enough. German ordnance officers reached similar conclusions on the Western Front. Captured intelligence documents from early 1945 include detailed sketches of the Garand's aperture mechanism. One report, recovered from a Wehrmacht ordnance facility near Kassel, described the site as providing an unfair advantage in open terrain engagements. The report recommended the immediate retrofit of German K98K rifles with similar systems. By the time the recommendation was made, German industrial capacity had collapsed. No retrofit program was ever initiated. The British had already understood the advantage. The Lee Enfield No. 4 rifle, introduced in 1941, incorporated an aperture rear sight. British ordnance authorities had been experimenting with aperture sights since the 1920s, and combat experience in North Africa confirmed their superiority. What made the American implementation notable was scale. The United States produced over 4 million M1 Garands during the war. Every frontline rifleman carried an aperture-sighted weapon. The British produced fewer than 2 million No. 4 rifles and did not fully replace earlier models until 1943. The Germans never standardized aperture sights at all. Soviet forces used the Mosin Nagant with a traditional open-notch sight throughout the war. Soviet doctrine emphasized volume of fire and close engagement ranges where the sight disadvantage mattered less. But Soviet battlefield reports captured after the war indicate awareness of the problem. Red Army snipers equipped with scoped rifles consistently outperformed German snipers at extended ranges, but Soviet infantry riflemen struggled in open engagements beyond 300 meters. There were limitations. The aperture sight required maintenance. Mud, snow, or debris blocking the small opening rendered it useless. Soldiers learned to keep the aperture clear, but in jungle environments like Guadalcanal or in winter conditions like the Bulge, maintaining sight clarity demanded constant attention. The aperture also reduced the shooter's field of view slightly compared to open sights, though this was rarely tactically significant. The larger ghost ring aperture compensated in close quarters, but some soldiers reported preferring open sights for fighting inside buildings or dense vegetation.
The most significant limitation was training. Soldiers accustomed to open sights had to unlearn ingrained habits. Early training manuals for the M1 Garand emphasized that shooters should not attempt to focus on the rear aperture. Some recruits struggled with this. They wanted to see the sight, to confirm alignment visually. Instructors had to drill the concept repeatedly. Look through it, do not look at it. Once this was understood, performance improved dramatically. By the end of the war, American infantry doctrine assumed aperture sight capability in all engagement planning. Fire and maneuver tactics incorporated the expectation that riflemen could deliver effective fire at distances exceeding 400 yards. This shaped how squads were deployed, how fields of fire were established, and how suppression was applied. The Germans never adjusted. Their infantry tactics remained calibrated for open sight engagement ranges of 200 to 300 meters. In open terrain, this gap was lethal. After the war, aperture sights became standard on military rifles worldwide. The Soviet AK-47 used an aperture rear sight. The Belgian FNAL used an aperture sight. The German G3 used an aperture sight. By 1960, no major military power issued service rifles with traditional open-notch sights to frontline infantry. The transition had been completed in a single generation, driven not by doctrine or preference, but by the cold arithmetic of hit probability under combat conditions. The M1 Garand remained in American service until 1963. Its aperture sight remained unchanged from the 1940 design. No improvements were necessary. When the M14 replaced the Garand, it retained an almost identical sight system. When the M16 replaced the M14, it too used an aperture rear sight. The design had achieved something rare in military technology. It had reached a form that could not be meaningfully improved within the constraints of iron sight technology. The small hole that German intelligence officers measured in frozen French fields became the standard through which all modern riflemen acquire their targets. The principle has not changed. The dimensions have not changed.
70 years of technological advancement in firearms have not found a better way to align the human eye with a distant threat using only metal and light.